Welcome to 1.4, which is actually going to evaluate our trig function. So we're going to use our 30, 45, and 60-degree angles that we know from our special right triangles. We're going to talk about how do we actually find these functions. So we still have the same ratios that we were talking about in the other video. Okay, across from our 45s is our smaller sides, and then to get to the big side, we have that square root of 2 times x, and then our 30, 60, 90 is the same with our x, square root of 3x, and 2x. Okay, so we are eventually going to get into what we call our unit circle, but for now, we are just going to look at these and try to decipher kind of how we figure these out based on the triangles. So when we're looking at these angles, right, the 30, 45, and 60, these are all going to occur in our quadrant 1 of our graph. So if we drew the first quadrant, right, we would have a nice 90-degree angle if we went from that x-axis out. If we don't move, if we just stay on the x-axis, this is 0. Obviously halfway between 0 and 90. Oh wow, that is not a straight line. Let me erase that. So probably about here would be your 45. Splitting those, but kind of closer to the 45 would be your 30-degree angle. And then splitting 45 and 90, but a little closer to 45 would be about your 60-degree angle. So just kind of give you a picture of what those kind of look like. So notice in this chart, we have not only sine, cosine, and tangent of the 30, 45, and 60-degree angles, we also have the cotangent, secant, and cosecant. So notice, for example, your sine are right here. And then notice the cosine is the reciprocal of those. So you will need to know these kind of from memory, but for the time being, we're just going to kind of use this chart. So if we were looking at, let's do an example. Just switch to purple. So let's say we were looking at, I don't know, the sine. We wanted to find the sine of our 45-degree angle. If we were finding the sine of 45 degrees, we would definitely want to look at our 45, 45, 90-degree triangle. Okay, so if we're taking the sine, let's just pretend we're going to focus strictly on, oh goodness, I erased that, this 45-degree angle, okay? When we find this, we would have the opposites of 45 would be our x's, and across from the 90 would be the x square root 2. So if we're focusing on that 45-degree angle, our sine would be opposite over hypotenuse, so x over x square root 2. We can simplify this a little bit for ourselves since we have x on the top on the bottom. This becomes 1 over the square root of 2. And we know that we cannot leave radicals in the denominator, so we can multiply the top and the bottom by the square root of 2, which gives us the square root of 2 over 2, which is why the sine, notice, of 45 is the square root of 2 over 2. Okay, if we were trying to find the cosecant, we would just flip that and we would get the square root of 2. Similarly, if we were trying to find, what was it? I'm just going to teach you how to simplify the radicals. If we had something like 2 over the square root of 3, remember that we again cannot leave that radical in the denominator, so we would want to multiply the top and the bottom by the square root of 3. We would get 2 square root 3 over 3, which notice that would be the cosecant of 60. It's just really important you don't leave the radical in the bottom, and also you cannot simplify a square root or a radical unless you have another square root or radical to accompany it. So the 2 and the 3 are on the outside here, so we could potentially simplify them, but they don't simplify nicely, so we would just leave it as that. Okay, so here's a nice little chart. You don't necessarily have to remember all the cosecant, secant, and cotangent, because as long as you know your sine, cosine, and tangent, you can just find the reciprocal of its matching pair.